Fairfield Group, what we do is we empower organizations with risk-based decision making. Right, the Fairfield Group is based out of London, but as Jameson well said, he's in the upstate New York, covering the U.S. market, and I'm in Latin America, in Ecuador, covering the Latin America market, and also doing part of the consulting. What we have is global reach, and this is how we want to see ourselves. We have a global network of consultants, ensuring tailored support for clients' worldwide needs. So if it's in the Middle East, if it's in Brazil, if it's in North America and Europe, etc., we have the people that could help us improve this offering, right? And our main industries, I would say, is manufacturing, financial services, energy infrastructure, which are the main ones, oil and gas that I forgot. And now we're going to extend a little bit more to mining and data centers. So we will have some master classes on that applied to risk management as well, right? Some of the global companies that work for us. And let me introduce myself before I start the case. My name is Gustavo Vinueza. For those who don't know me, I'm a systems engineer that went through the bright side of risk management, quantitative risk management. And I very much like how quantitative risk analysis can let you model very, very nice things like the one that we're going to see today. I used to work at Palisade for 12 years, and I work at the Fairfield Group for the last 2.5 years, maybe. I work, I'm a colleague with Jameson, and if you know Doug Oldfield or Craig Ferry or Dan Goldrum, well, we all work together, right? Now, thanks again for coming. This is the case today. The case is an innovation portfolio, and the innovation portfolio, we're going to add Monte Carlo Simulation to it. And on top of Monte Carlo Simulation, what I want to propose is to add AI or generative AI as a true copilot, right, during its creation and use. You can or you cannot use this portfolio with AI. It's totally up to you. And hopefully you'll see all the case uses that we prepare, right? What's the stack or the platform that I use? I use, of course, MS Excel with model risk, right? And I use some LLMs and software based on LLMs for the AI part, like ChatGPT-5, 11 Labs for a voiceover, Perplexity, right? A couple of additional things, right? So you can see all the different use cases that we have, right? Now, how AI enters the team. So generative AI, I try to include it during all the process, right? As a tool for research, as supporting, as validation, optimization, as a presentation copilot, as interpreter, etc. Always with the role of curating and improving results. So this is not the case, and this is the place where at least I feel the most comfortable, right? AI will not generate the information, right? AI will curate, will assess, will review the information, and send recommendations, right? So I'm not letting AI drive my results. I'm not letting AI tell me what to do, but to help me with all this big, enormous memory that it has to say, you know, Gustavo, this is not going to be great there. Why don't you try a different point of view? Why don't you see this in a different way, right? So this is the best way after doing this, all this research on how it's going to be done. Typical AI cases, right? We have a context video that I'm going to show you in a minute. Some information, research, change of capacity in the portfolio model, presentation, etc. So what I will do, give me 1 second. I'm going to stop sharing and share again. But now I'm going to share with sound. So give me 1 second. You go. And you will see why. Because what we wanted to do, we wanted to introduce this company, right? This company is called Sierra, right? And I generated, and you will see, hopefully you like it. I generated this.
Every bold idea starts with a question. For us, it was simple. What if connecting devices could be effortless, affordable, and universal? That's how Project Sierra began. Our mission, to design an ultra-low-cost IoT protocol that
You see, we wanted to design an IoT protocol. That's the main idea of Project Sierra, right? So I'm going to put a little bit here, right? And the idea is for the project to be very low cost.
Inside Sierra, 4 agile squads work together, each sprinting toward the same goal: to make intelligent connectivity faster, lighter, and universally compatible.
Right. So maybe you have 4 teams in Project Sierra, right? And what I'm going to show you here, and well, this is the spirit of the company and all that. And I want to show you here the type of projects that we have.
Strengthen what already works, improving reliability, refining design, and scaling efficiency. Our adjacent projects explore new frontiers, testing ideas that stretch our technology into new markets and applications. And our transformational projects, like Sierra and Zulu, are where we take the long view. They're multi-year bets, built to redefine how technology integrates into everyday life.
Right. So the main idea is that you have 3 types of projects: core, adjacent, and transformational. Right. And what we did, why is it that we did? Because you will see, but what does it to? How is this related to all of that? Well, what we wanted to do is
built to last. The future isn't something we wait for, it's something we engineer. One project, one idea, one connection at a time.
Why is it that we wanted to do this? Because we wanted to do an onboarding video. Why is that? Because I imagine that you have your company, in your company, you have these new people that come to work, and you have to explain, and you have to wait, and things like that. And maybe you can say, well, how long did it take? And for me, doing this took around 45 minutes. All the video with the music and the script and all of that. So this is something that you will, I will send you the presentation, but if you use Canva and the script with ChatGPT and things like that, this is something that you can generate in 45 minutes. So this could be a really good initial use. After that, I'm not going to show you this video. What we did, we generated a market research case. Right? And this case, what we did, we generated what we call the deep research abilities that you have in a search engine called Perplexity, right? To generate a deep market analysis of the IoT hardware and protocol ecosystem, right? And we generated this PDF file. This took around 5 minutes. And of course, again, I am not saying that this was the correct thing, right? I'm saying that this is a good initial. And it generated all of this. It was a complete market analysis of the IoT industry. Why is that? Because we are in this industry, and what I wanted to do is I wanted to show you another use case. For example, for somebody that's new to the team. So, new to the team needs to understand the projects checked, and now it needs to understand the industry with this, right? 5 minutes. So far, we haven't used even an hour, and we have all this information for the model. Now, let's go to the portfolio model, right? The portfolio model is here, right? It's not a very big file. And as you can see here, right, it has different projects. You see Project Alpha, Project Beta, Project Charlie, Delta, etc. Each one has phases, 1, 3, 6 phases. Each one of the phases has a different probability of success, like this, right? Which is a Bernoulli distribution, meaning that you see here, the project can, when you have a 1, that means that the project succeeded. If you have a 0, that means that the phase didn't succeed, meaning that the project subsequently didn't succeed, right? Like this. Plus, you have a duration for each phase. You see here, phases are concatenated like waterfalls because they are stage gated, right? And of course, the phase's duration is uncertain, so that's why you have this. Plus, you have a reference budget for each one of the phases, right? And the phases, they also have a different volatility level, like this, you see? So you have volatility levels, right? Like this, right? So for example, in this case, this project didn't succeed, you see? So I only spent the total in phase number 1, and it didn't succeed. But at some point, let's take a look here. You will have, for example, here, it succeeded all the phases, so I have to spend all of that. Why? Because each one of the phases succeeded. So that's how these projects work. How, in which industries? Innovation, research, sometimes in manufacturing, as I showed you before, in technology, pharmaceutical, big in pharmaceutical. So this is the type of project that you will have, right? What else you have here? So we have 20 projects. This is what we have here. You see, you have 20 projects. Some of them are core, adjacent, transformational. Each one has a different date, right, of start. And we even generated a calendar like this, where you can see real time, you see, how the projects adjust. Why? Because even though the start date is the same, not the duration of the tasks. So if you see it like this, take a look here, right? If you see it like this, you can even see the portfolio of the projects real time, like this, right? Of course, I wanted to let the start date also to fluctuate, but these are improvements that you can generate into the model, right? And these are the rules, right? So you have 20 projects, as I showed you before. The duration of the project can be normal, triangular, or paired. The cost could be high, medium, or low volatility with normal distributions. We didn't include correlations or interdependencies between projects. And each project has a different set of stages with state gate probabilities like this, right? Which is really nice, right? And every stage has a different probability. They are independent between each other, right? If you finish a phase, even though if you don't succeed, you will have to exhaust the budget for the phase, right? Every project is independent of each other, right? Now, let's go to Project Alpha. For example, in Project Alpha, take a look here. What we did, we generated the project as I showed you before, with the duration, the survival probabilities, and the budget, right? So in some cases, you remember you have a duration distribution, a probability to success, and a normal distribution for the budget. You can use any of them. Remember, you don't have a limit on the number of distributions that you use. In the scenario number 1, you see, you have the survival equals to nil, meaning that you only spend 1.96 million, but you don't spend much more, and you don't have a survival, right? The project didn't survive. But in this case, the survival was a success, right? Meaning that you will have to spend all of this money on the project, right? And this could be the other case, right? Where you have a project that succeeds. So what we did, we generated, let me show you here in the model. After you run a simulation, right, you will get something like this, right? I go here in dash number 1 in the probability of success. Let me see here in Project Alpha, and what you will see, I can change the history to a histogram like this. So this will be, if I'm not mistaken, let me see here. I just don't want here. No, this is going to be Project Alpha like this. Let me see that here. No, it's the histogram plot like this, right? I think it's a little bit different in the one because I made some changes, but this is going to be that, right? So this is going to be the total expenditure in Project Alpha, and you can see all of them, right? Depending on how you set them up, all of them can be here, or I can do an overlay with this, right? With a cumulative graphic like this. So I can set up as many graphics and visualizations as I want, because this visualization platform that we have here in Model Risk is outstanding. So what I show you here, let me go back to Project Alpha, was this, right? So this was the total expenditure for Project Alpha, from 0 to 18 million, right? So what I said is, look, I am not really good at understanding this, so please help me understand it. So what I did this prompt. So all the prompts are going to be here in green, and you will see that there's a slight change of font for the responses. I'm not going to read through everything, of course, right? So what I did, I included the this report and I say, look, I have 1,000 samples. I took the samples, right, and say, generate a TLDR, too long didn't read, right, for somebody not versed in Monte Carlo, like this. And also Project Alpha has 5 phases and a reference budget of 11.4 million. Units are in the millions. Page 2 should be a little bit more technical. So here what it is, it's the output of what I included. I included the samples of the distribution, right? You remember that here in model risk, what you can do, you can come here and say insert list, and you will have access to all the samples of the distributions, of all the distributions, the inputs and outputs, you see? So I can say, give me just the ones from alpha, like this. Or give me the ones, here you go, for example, here, ones from Project Alpha, and I have them, so I can copy that, and I can put them into my Gen AI if I'd like, right? So you can do very, very automated things like that. And the second part, remember that I asked for it, is the interpretation for non-technical readers, right? This suggests that Project Alpha remains with a manageable risk level. There's a moderate probability that costs will exceed the plan, etc., etc. So again, what should I do with this? Of course, never copy and paste. I will take this and say, well, is this more or less my interpretation of it? You always have to have your interpretations first, right? Otherwise, I don't think that it's going to be of a good use, right? If you don't get it like that. Now, what else did I have for Project Alpha? Second thing, and I remember that this, as we are doing this for me, in my case, for more than 15 years. And always the interpretation of cumulative discrete distributions, it's difficult for people, right? So what I did, I generated an output in the model for the maximum phase of Project Alpha. So that means that this histogram here, well, this is not a histogram, this is a cumulative curve, right? A cumulative density function that you have here is going to show, right, how many times it reaches to phase 1, phase 2, phase 3, etc. But I said, explain to me this graphic in 2 paragraphs, right? Assuming I know nothing about simulation, and you use examples. And what it did, I really liked it. It says, to understand this, right? It says, to understand this, you have, imagine planning a cross-country road trip with 5 checkpoints. You see, sometimes everything goes perfectly and you reach the final destination. Other times, bad weather or car trouble might stop you early. So the histogram is like a recording of 1,000 trips, and it tells you how often people got stuck, etc., etc. Right? So think of the y-axis and showing how often each outcome happens. Right? Shorter bars like the one near phase 5, near fewer trips, etc., etc. So you see here, it helps you understand and helps you explain for people that it's not totally, versed or not used to use Monte Carlo simulation all the time, or even statistics. So it really helps with that information. That's one of the things I really like, is that sometimes the comparisons are really good and they are outside of really thinking outside of the box here. So that's one of the things I really like about this case, right? Like this. Now, other thing that I did, I generated a sensitivity analysis. And what I said, look, we're going to have 3 different scenarios. One scenario is basic Project Alpha, right? Here. It's Project Alpha as it is. Remember, we have our 11 million budget here. But what happens if we have a technology breakthrough, meaning that Project Alpha is going to be accelerated, or if we have tighter regulation, so Project Alpha is going to be worse, like this. So what I did, and this really works, I took this, copy that, and send it into the prompt. I copy the graphic, send it to the prompt, and say, well, explain to me, and it generates this really nice explanation about the red curve, blue curve, etc. Of course, I have to set up all of that in the prompt, but the explanation was really good. So that's why I really like that, because you see, again, it's your copilot. It's not like you're leaving it to run the Monte Carlo and set up the scenarios for you, but you're one-to-one. It's like talking to a colleague, right? So that is AI case number 1, interpretation of results, right? Plus what we've done before, the onboarding video, the research, etc. But this wasn't one project. What if we're going to take a look now to the portfolio? Remember, we have 20 projects, right? So couple of things that we're going to do with the total portfolio. You see that the reference value was 218 million, right? Which is here, you have 80% probability of surpassing that, right? So the first thing that we did is like, look, I don't know, I'm not as good as that. Send me or generate a dashboard for me. So he generated this because I told him that I need some PAT here, and it knows that I always ask for PAT, right? Which are the projects at risk, etc., etc. Plus, it generated this very nice project setup dashboard, and I created that in Excel. So the project dashboard that I have in my model here, right? This one and this one, they were created based on what it did. I created one that was like 80% what I would do, and I added, for example, this flag, this probability of risk, etc. It was really nice. So created that. After that, what I did, you remember that I show you that I had the cash flows, right? Here, in the model here, in the calendar, let me show you down here, I have the cash flows, all the cash flows for all the projects here. And these cash flows, right, you see, they move each other. Why is that? Because all of them have the uncertainty. So what I was able to do was to run the simulation and generate this P10, P50, and P90 with these both sim percentile models, right, that I have here with this function from both model risk, right? So using this, what I did, I took all this information, and there are two things that you can do. You can take this and generate this graphic yourself, like this, right, if you like. Or you can take all the different graphics yourself. Or what I did in this case, I said, look, I have all this information from the samples. Why don't you give me a graphic? So the graphic that it generated, the other one was the complement. It was my 1 minus. So this generated the right graphic here, right, using the P10, 50, and 90 for each month, right? And I said, I need you to visualize this information so I can better understand what happens with the flows. Why is that? Because I'm concerned about how much am I going to spend every month, because I have limits, right? So how is this going to be during the complete life of the portfolio, right? And it generated this. So of course you can do this in Excel, you can do that yourself, right? After that, I said, please help me understand it. And it generated a very nice interpretation on how to do it. Right? And here is where it starts to get very, very nice, because this is like, again, talking to somebody that could understand and recommend things. Like, for example, here, it said, well, I have an 8.5 million cap per month by finance. That means that I cannot spend more than that, right? So here what it says is, look, based on the portfolio's median, my P50, if I do 8.5 cap, 13 months, I am over that. But if I do 9 million, I have only 10 months. 9.25 million, I have only 10 months where I surpass that, right? And it generated, right, this, you will see. It generated this. These different lines with the different limits, you see. And the 9 million, it seems that it's manageable because only 10 months I am on top of that. Of course, I can say I don't have any flexibility. What I can do there, if I don't have any flexibility, is I can say, well, I have to have 0 months that are capped with that, right? And what I said, look, there's a valley here. There's a valley where I have very less expenditure here between 2025 and 2026, right? That I should balance. So what it does, take a look here. It takes the peak, erases that peak, the same thing with these two, and transform that information into additional expenditures here and here, right? So balance it out, which is great because that's exactly what you will try to do by hand. You see that sometimes we just have to move the date and try to move it by hand and see, well, what are going to be the flows. Of course, you have to be careful about this, right? The hallucination. In this case, the first time that I run it, right? My total was around 119 million, but I have 159. So this is where you have to be very careful, because these things, they work, but you have to be very, very careful with those, right? Once you have that, right, I have to include them here. It gave me a difference report, right, of my 119 million. Imagine you have this capability now. You're doing a cash flow, and with this cash flow, you see that it's very demanding in terms of your cash flow for the month. So it generates automatic and optimized cash flow, right, like this, which is rebalanced, you see, and it doesn't surpass the 9 million limit, and it makes 119 as well, which is great, right? Because you see where are the months and where is it that you're going to spend more. Once you have that, you will end up with this, right? With this rebalanced cash flow. So what happened is that, of course, I restructure the model. There's another model over there that generates that cash flow, right? Which is here, right? So that was the main idea, that the model will generate this, and what I can ask the generative AI, I will say, look, please in this case, reschedule all of these dates, or or maybe optimize some of these I don't know, probabilities of success, or do a benchmark depending on the nature of the models, etc. So you can have all of that information. Why is that? Because you always have, and I will make it very small here so you can picture it, right? Here, you always have a capacity limit, right? And normally when you have a lot of projects going on simultaneously, so this is where you have to be more careful, right? So it rebalance, generated this optimized picture. And finally, we wanted to do this NPV. And you see, this is what happens. The following assumptions were included. A success factor with increases with the type of project from 2.5 to 7x, right? So if it's a core model, perhaps it's going to give us 2.5x. But if it's a transformational model, it's going to give us 7x, right? Number of realization years, what's the type of the project cost, the success factor, etc. for the model. And what I said, give me the discount rate that I should use to discount all of the different project types. So you see here, so the core projects are going to be 12% to 15%. The adjacent are going to be 17, and the transformational will be 25. And here again, I should check that with my documentation or with the best practices of my company, right? And these are the ones that I utilize to do the cash flow. And these are the ones, you see, this is the expected NPV. This was my expected NPV. And this was my risk-adjusted NPV. This, you see, much more conservative. Why is that? Why is that? Because I introduce the same adjusted ranges nominal. You see that the majority of times we use the same discount rate for the same project or the same portfolio. In this case, it asked me to generate different discount rates for the different flows of my project, and I was able to do that, right? So remember that here in the, I'm going to go back to model risk here, right? That you can generate, change that here, the different histograms one on top of the other, right? Like this. Here I have, for example, my expected NPV versus the risk-adjusted NPV, like this, you see? Or I can see them like that and say, well, what's the probability for my NPV not to be in zero, for example? I can go here. The visualization is, as you could see, you could do so many things. For example, I can add here and say I have an X of 0. Why? Because the limit of my NPV is going to be 0. So you see, you have in my adjusted, you have only 1% probability of being more than 0. Right? I'm sorry, you have 99% probability of being more than 0, and the other one you have 92. So you can generate all of these additional calculations that I didn't include into the model because they were too big, right? But that was the main idea of it, right? Remember, to be able to include or to generate this decision framework, right? How is it that, what's that we're proposing now, right? What we're proposing is that you build the model as we usually build it, right? With your constraints, with the typical granularity decisions, with all the stage gates, the duration, the budget, right? What else you can do here? You can add resources, you can add a lot of things, right? You add Monte Carlo simulation, and for this, of course, you will utilize model risk. And you see that how easy it is, right? You just add things on top of each other in Excel. Then you have another element, new element, which is AI. And AI, as I said, right, it's used as a copilot, not Microsoft Copilot, but as a copilot that gives you, support, sometimes interpretation, visualization, etc. Right? That's going to let you grow and build all these improved models, because that's how I see it. I use AI not to build my model, because the model, I have it in my head and I know how to do it, and I need to know because it's the business. It's mostly for validating decision making, because if we're going to spend 120 or 150 million, at least I should check. Of course, you will have your team, but this is, as I see it, as an additional check, right? What's the value of this check? I really don't know at the moment, right? I couldn't say, well, if I have 4 peers and they all have more or less the same level of knowledge, each one is going to be 25% each. Maybe AI will be 10% compare, maybe, right? But the idea is to validate all these additional options that AI is telling you. Then you have the decision feedback, right? So from here, this is like the added value change that we have, right? The traditional financial or innovation model normally assume fixed inputs, right? So what we did, we added Monte Carlo simulation. Why? Because we wanted to introduce probabilistic thinking. But now we have a new, right, a new team member, which is generative AI, right? Generative AI is going to be acting as the third layer, right? Interpreting results, generating adaptive insights, and refining parameters dynamically, right? What's going to be the result? The result is going to be a continuous decision loop that learns and improves from every project cycle. That's the main idea. That's the main idea, that we are able to utilize AI to improve our decision making as well, right? So AI is not going to decide yet. AI is going to help us do that.